Welcome to today's Energy Central webcast, Integrated Operations for Nuclear, ION, a modernization framework for fleet sustainability and capacity expansion. Before we get started, a big thank you to ScottMadden for making today's event possible. Now I'd like to hand things over to our first speaker, Luke Martin, to kick things off. Luke, welcome to the event. You have the floor.
Thanks, PJ. And thanks again for Energy Central for hosting and everybody for joining us today. I'm Luke Martin, partner at ScottMadden, where I lead our operational technology, OT, AI, and nuclear modernization work. Before we dive into the content today, we wanted to provide a bit of context on where this work comes from and how we're approaching today's discussion. ScottMadden has been working closely with Idaho National Labs, INL, for more than 8 years, supporting several DOE-sponsored research initiatives, industry pilots with nuclear operators, and applied modernization across the U.S. nuclear fleet. That collaboration started under the Light Water Reactor Sustainability Program, where the focus is not just on technology upgrades and research, but really rethinking how nuclear plants are operated, supported, and governed over their long asset lives. As PJ alluded to, this is focused on integrated operations for nuclear, or ION in short, which has emerged from work that is really practical and focused on an operating model grounded in real utility environments, the regulatory and NRC constraints, and our implementation experience. So this has always been focused on utility-driven and industry-driven efforts, with INL playing the role of research and convening. ScottMadden's focused on translating that research into something that operators can actually use. So today I'll be joined by three of my colleagues who bring different but complementary perspectives. Brian Shez, who has spent many years working at operating plants and leads a lot of our hands-on modernization work. Alex Taucoat, who focuses on our digital and AI efforts and has studied the business case on AI in nuclear environments. And then Morgan Shattuck, who is also a nuclear engineer and has unique perspective based on time spent working with our clients that are owners, operators, and developers. Also wanted to set some expectations up front today. Today's discussion is intentionally focused on the conceptual design of this operating model. We're not going to walk through any specific utility playbooks, procedures, transformation plans, so keep that in mind. Our goal today is really to frame the industry challenge, share what we're seeing across utilities in our lab work, and then discuss how integrated operations can support near-term performance and then the long-term capacity expansion goals of the current administration. With that, let's start with what's driving expansion in the nuclear industry and why these operating models are becoming a critical part of that conversation. So PJ, if you could advance to the next slide, thank you. So 5 years ago, the industry was really focused on survival. When we got started with the ION journey, it was really about competitive prices from natural gas in terms of competing generation and really looking to sustain the future of the long-term outlook for the U.S. conventional nuclear fleet. A lot has changed in 5 years. And today, the challenge is really now scale. And so, as you can see here, it's been all over the news, but large loads from AI and data center demand, the specific federal targets and policies, so aggressive goals, roughly 5 gigawatts of capacity expansion spelled out in the latest executive orders, and then system reliability and grid constraints to make all this work together and ensure reliability of the broader grid. So expanding capacity not only requires modernized operating models, not just additional megawatts. And so with that, I'm going to turn it over to Brian Shez. Brian's going to walk through why ION was originally developed, what we were seeing across the existing fleet, and how modernization challenges have compounded over time. Over to you, Brian.
All right. Thank you, Luke. And thank you, PJ, and our friends at Energy Central for hosting this webinar. And thank you, everyone, for joining. ION, so we're going back to when the ION business model was constructed. And like Luke mentioned, there were several things going on in the industry that really generated an idea of doing things differently. So the researchers at INL and ourselves looked at across the nuclear, the domestic nuclear fleet, and we saw aging and obsolete plant systems. That in conjunction with license extensions, right? And so one of those two don't necessarily mix in many cases. So something had to happen there to sustain the fleet. Then another one that we saw, and I think a lot of those who work in nuclear can sympathize with this, is that there's data silos that exist across the fleet, and the applications, business applications, and other data was housed in its own place, in its own application, and really not accessible to other applications or to other computer programs, which has become all the more essential in today's world of artificial intelligence emerging in the business world. Another one, and this is based on feedback as well from our utility friends, that workers were coming in the door and they may have understood that nuclear power was not necessarily at the cutting edge of technology implementation, but once they realized that they may be spending the rest of their career maintaining and updating 1970s technology, you can understand where technical folks might feel a little friction in their career path, so to speak. So interest in new technology and keeping workers around was very much at the forefront of the ION business model as it's constructed. So we'll go to the next slide and talk about, this is just what we've got here is just an illustration of the existing model like I just described. And then below that, the ION model, just a basic illustration to get everybody acclimated to what this model is about. And here you can see where data is shared amongst plants in a fleet, and maybe potentially even plants, outside of the fleet, sharing data with each other for the reasons of, for instance, AI-enabled business processes. The more, in what I've learned about AI, is the more data, the better, right? So data is a big part of this, and central office is not just in this governance oversight mode. It's part of the fleet. It's part of the solution that is creating the ION model. And then you'll also see modernization, and in this context, we'll call modernization, that's the modernization of obsolete components, INC control systems, and then innovation. So innovation like, new technologies, robotics, things like that are going into plants that help them modernize and become more efficient. Okay, we'll go to the next one, please. This is a little more detailed look at the ION model and what it is intended to address. And the nuclear utility does feel these and many other forces, of course, but there's internal forces and external forces. I mentioned obsolete INC systems a couple times already. So ION, a big component of ION is replacing those systems and making them useful to future operations in an integrated way. O&M spending, it does address O&M spending. O&M spending is always a big concern among our nuclear utility partners. And the ION model does address O&M spending and seeks to become more efficient in that realm. And the ION model is this last one on the bottom here in the red. The ION model is not necessarily about let's just implement the latest thing, right? It's not about that. It is about coming to find a solution for ION business transformation that is site specific. And as we know, and we found, a couple of the associates at ScottMadden and others working at nuclear utilities, each plant, even in a fleet mode, has its own has its own culture. And so ops may not be ready for change, but maintenance is, or engineering might be resistant to a new application, but RP is ready for it. So ION addresses that and make sure that the solutions that are being implemented are not just cookie cutter, like everybody has to do 1, 2, 3, 4, and 5, but there's an actual plan put in place that's unique to each utility. Moving over to the yellow side now, the external forces, skill shortages. ION wants to, the methodology also takes a look at, okay, what's the labor market in your particular location, whether it be Texas, Pennsylvania, Illinois, California, Florida. There might be an abundance of operators, but there might be a lack of INC technicians. There might be an abundance of engineers, but not enough training people. Okay. So ION also takes a look at that. The methodology takes a look at this is also kind of in the readiness for change. It's saying, okay, we have these issues with skill source, so let's apply some of the ION initiatives that will address those skill shortages that your plant is experiencing. And then similarly to O&M spend, I won't get into detail on these. Market price uncertainty and inflation. The ION model also addresses costs, right? And so it is going to push against inflation and market price uncertainty by lowering costs and making the plant more stable from a financial perspective. Okay, so that's a lot about ION. And if we go to slide 9, please. This is an example. This is just an anonymized, or not even anonymized, but an example, not specific to any one particular plant. But what happens is, within ION there are 40 some initiatives that can be taken off the shelf and say, okay, should we apply this initiative? Yes or no. And let's say one particular plant, we're working with that plant, and we're saying, okay, we've done the assessment portion, and now let's look at a business case that can be made for each one of these initiatives. And there could be 20, 30, 40 of those that we pick from. We look at the business case for each one. So we want to make sure that this is actually going to bear fruit once it's implemented. And some may bear more fruit than others financially. And so we rank them and we put them in order, and we assess those together. And then we pick the ones that are most important to implement right now. They could be, for instance, like these, advanced training technology, robotics, electronic work packages. And then at the bottom, underlying all of this is digital INC control room upgrades, so we've seen a lot of our clients, do analog refreshes just to keep existing systems going and eliminate the obsolescence issues that's causing inflationary pressures on the utility. So that's what we do. We get a handful or a group of ION initiatives together that look appealing. And then on the next slide, we put those into a 5-year plan. This is what we call an ION business transformation roadmap. So you can see, in this particular case, we would like to start with advanced training technology. Let's start implementing that now. The utility is ready for that. The utility is open to that. And then in this particular case, there was a revenue generation project. And then next we have AI-enabled digitalized workflow. And then we'll step into some other ones, ending with robotics at the very end. So what we want is a 5-year plan. We don't want to just do whatever the shiny object is this year. Let's go after that and spend a bunch of money and spin up a bunch of people, and then kind of step back and say, okay, what did we accomplish? We want to have a 5-year plan. We want to have a strategy that's going to transform the utility into that model that we were seeing, where it's opening up data sources to enable these initiatives to work together and lower costs and bring about stability in the nuclear power plant. Underlying all of this, of course, digital INC is a big part of it. And again, I'll say, digital INC is not a panacea, and it's very expensive. We do know some utilities are going after that full bore. Others are a little more hesitant, and that's okay. And there's other options out there. There's analog refreshes. There's other things that can be done to keep these systems going. I guess all that being said, ION is not just a cookie cutter. It's not just the same thing for every plant. It's highly unique to each individual facility. Okay, and then lastly, on the next slide is some of the, if you've been paying attention to nuclear, you're understanding that there have been some executive orders signed, and one of those half is reinvigorating the nuclear industrial base. And ScottMadden and our friends at the DOE, INL, and the LWRS program are exploring ways how ION can support and even accelerate these executive orders that have been signed by President Trump. Okay, that's all for my section. I think I'll bring Luke back in and see if there's any questions.
Yeah, thank you, Brian. So you mentioned the vast number of ION initiatives. There was roughly 40 of those. So do all plants need to look at implementing those 40 different initiatives or focus areas to see benefits?
Well, yeah, I guess short answer is no. I guess in my in my perfect world, I would love to see all of those initiatives be put into place in some way or another. It's certainly not the goal though, because as you can see, there was a 5-year process and there was a lot to do there, just in that one example. So yeah, this is not like, okay, everyone has to do 40 things before ION is implemented and you start seeing benefits. To start seeing benefits, I may not have mentioned on the previous slide, but you can see the cost savings start to build over time when we model all of this out for the utility.
Excellent. So you also talked about workforce. How does ION help the workforce? You talked about kind of scarcity of skilled labor coming in. We've seen that across the industry and especially very specialized skills. Maybe you could speak to how ION helps the workforce and the multi-skilled components.
Right. ION does one component of ION is that the workforce, like you said, Luke, is expected to be multi-skilled. So a lot of the siloed barriers that are now in place between, let's say, operations in RP, for instance, the ION lowers those barriers, and so the workforce then is seen to be more flexible, and maybe even doing things for another site or another facility while you're sitting in your current site, or you're traveling to another facility multiple times a year, or there's some centralized location of experts in this one particular area. It expects more of that from the workforce. And then the only last thing I'll say about that is, addressing the workforce, you can see where people who are coming out of school now or in the last 5 to 10 years could become very excited about all of this and wanting to build this for themselves and build a career out of this and putting this in place in the current domestic fleet.
Thank you, Brian. So PJ, if we could go to the next slide. Alex is going to touch on how AI is a component of the integrated operating model. And a lot of interest right now is focused on AI, and understandably so. What we're seeing is that AI value is often constrained by the operating model readiness and a number of key factors, whether those be data governance, cybersecurity issues, and other hurdles that have to be overcome. Alex is going to talk about where AI is actually delivering value today related to the U.S. nuclear fleet and where we see utilities and operators getting stuck. So, Alex, over to you.
Thanks, Luke. So, Brian's covered in some detail what we can say, the first phase of ION, the background to its vision, the objectives, how it's been developed and applied at some, in different utilities and different contexts and nuclear plants. So now we're going to talk about, how ION is being adapted, is in the process of being adapted given the new context of new forms of AI. So I'm going to talk through, as Luke said, discuss some of the real examples of AI deployment in the nuclear industry today, some of the challenges we're seeing, and then where the ION, or I should say the ION AI framework, would address some of these barriers that we're seeing. So talking through this first slide, it kind of builds on what's been discussed and introduced by Luke at the beginning. The original context to ION, the original impetus behind ION was essentially defensive. So, this was in the context of the 2010s, when, natural gas generation was very much kind of the boom electricity generation source. It was very cheap. At the same time, demand for electricity was, relatively stagnant, growing relatively slowly, I'd say. So nuclear plants were fighting for economic survival. They were fighting to be cost competitive with that, particularly natural gas. Now the context is really very different. First, many of the efficiencies that we were looking to achieve in the nuclear industry have been achieved, and we're seeing record high capacity factors across nuclear plants. We're also seeing, and this is, been introduced by Brian previously, there's really bipartisan policy support for nuclear. Not just this administration, the previous one as well, and with very expansive targets for capacity growth by the end of the decade and by mid century. And of course, the key part of this is the rapid demand growth being driven by AI data centers. So that, that's the sort of the key moment we're in is, as we all know, this dramatic expansion in demand for electricity, which is really the first time in many decades we're seeing that. And these same AI technologies have the capability to unlock, as we see it, some of the new operational capabilities that the nuclear industry needs, and that ION was kind of developed to facilitate and to fuel the rapid expansion in the industry overall. For those of you who've been involved in the industry and been around conferences over the last year or two, I think there's strong consensus across the industry that AI is really the key to unlocking new capacity, and at the same time enable fleet scale operations that ION envisages. So, as we kind of describe it, the next evolution from integrated operations is kind of intelligent integrated operations. So many of the initiatives that Brian's touched on, predictive maintenance, workforce planning and optimization, remote monitoring, AI potentially has the capability to make these work, not just on an individual plant level, but on a fleet scale, which is the critical component to scaling these technologies and seeing rapid expansion and efficiencies across the nuclear fleet in the US. I think important to mention, it's not on these slides here, but the workforce benefit of deploying AI effectively. We've all kind of been aware of the discussion around the concern about the retirement of skilled workforce, happening particularly since COVID. And I think one of the expectations or hopes of AI is that it can help to mitigate some of these issues. For instance, as a support tool for senior engineers, and also to help with bringing new staff up to speed faster. So, that's an important add to the capability of AI. AI is a huge enabler, obviously with the potential to revolutionize nuclear power and power generation, across the US. But there are significant challenges, and we're going to get into those just in a sec. There are, certain foundational capabilities required to allow AI to work effectively and effectively at the fleet scale. So that's what we're going to dig into. So, move to the next slide. Next slide, please. Thank you. So, first, we're going to talk about some examples, some use cases of where we're seeing AI deployed in the nuclear industry today. So, we have different AI applications at different deployment phases. Some in production, very much seeing real-time ROIs. Some much, in the piloting phase, kind of leading on from maybe some of the early deployment successes, and then some still emerging, and maybe you could say, challenged by certain uh, technological or organizational things which the industry needs to work on, and which AI with the Ion AI framework is kind of designed to address. I think it's important to emphasize, everyone's talking about LLMs, right? Talking about generative AI, but we want to emphasize that there's a range of AI capabilities. Traditional machine learning was, kind of that's been in the works for a long time, been deployed in many tools across the nuclear industry, and other electricity generation, computer vision technologies. So we're not just talking about generative AI, although that's obviously much of the excitement is there. So let's talk about some examples of use cases. So in the deployed category, I think we can say, again, preface this by not focusing too much on LLMs, but I'm going to dive right in. So document search, this is the universal entry point, and the most obvious mature application of LLMs. It's what everyone is using for their daily life. And for the nuclear industry, we're talking about custom chatbot style interfaces. These are purpose-built systems trained on plant data, and connected to the utility-specific repositories of documents. So this is augmented retrieval capabilities. It gives utilities the ability to query actual procedures, operating experience records, and technical documents. So these are really powerful tools. They're in deployment. They're it's still early, but we're seeing value, and we're seeing return on investment in these basic chatbot functions. But as I said, using and working with specialized nuclear vendors, there's a high level of I think satisfaction with some of these early deployments. What else to mention? I think maybe just touch on inspection automation, as this has been in the works for a while. We're not talking about necessarily generative AI here. There's some fairly mature use cases. We're talking about, for example, autonomous robots for visual inspections. That's a use case that we're familiar with. So moving to piloting, so these are systems which are being tested with real data and real users, but they're not kind of fully mature. We're not seeing them rolled out across plants or certainly across fleets at this point. So maybe talk a little bit about predictive maintenance. So utilities have been deploying machine learning for anomaly detection for some time. And I think the advent of more advanced generative AI is allowing utilities to solve some of the issues they had of inaccuracies of anomaly detection tools. We're seeing utilities using AI for their CAT processes. So screening condition reports, root cause analysis, and then trending these issues across the thousands of issues to develop to see real value. So I think some of the examples and use cases we're seeing here, they're close to being rolled out. And I think if AI can handle predictive maintenance effectively and solve some of those problems, then this is a potentially huge ROI for nuclear plants. Maybe also just touch on work planning and scheduling. This is being deployed. Again, this is kind of another huge use case. And we're seeing this, built out at the plant level. If this can be effectively scaled, this is could be a big deal. Also seeing outage planning, AI GPTs, so autonomous AI workflows being deployed. And then emerging applications, So these are things kind of in research, applications which INL and ScottMadden and ourselves are involved with in our work with INL and others. So maybe just focus here on control room decision support. I think important to know that we're not talking about autonomous control or autonomous decisions. It's very much the operator is still very much in the loop. It's about providing operators with analysis and recommendations that they can help them make decisions, potentially in the future, real-time decisions. And that's very much something that could be beneficial, but we're still in the emerging phase there. I think it's important to say, as everyone knows about LLMs, extensive validations necessary as you deal with more complex data. Larger data sets. You can, the current generative AI technology, you can suffer from some inaccuracy issues. So, okay, I think we'll move to the next slide. So, touch on just broadly what are the challenges we're seeing with AI, with scaling AI, and then how does that lead to some modernization needs and the ION framework. So in several use cases, in particular, moving from pilot to enterprise deployment, moving from a single use case to multiple use cases, or from a single unit to an entire fleet. There are some, I think, systemic challenges that we're seeing, and the industry at large will look to resolve before AI really revolutionizes the industry. So first one, I think workforce adoption is a big deal. I think a lot of the issues here are not necessarily specific to the nuclear industry. But I think important to know we're talking about people using the tools and being able to use them effectively. Also, I think this has a change management component here, skepticism and concern with the accuracy of some of the AI, especially some of the very recent LLMs. There's some resistance amongst more senior members of engineering staff to the use of AI to augment but not replace the human operator, the human technician. There's concerns about how AI could be misused, especially for junior personnel, or how it could impact the way that engineers and young tradesmen could develop their skills. I think these are questions we're all dealing with. Will AI interfere with that? Some utilities are finding that once new LLMs get deployed, people don't always use them. They'll test them, and then they'll find that over time because there wasn't sufficient training or rollout support, people get frustrated and go back to the old ways. So this is an important challenge. Second challenge, I think, and this goes for all, all AI and beyond AI, really. Data quality and fragmentation. You can't build intelligent, reliable systems on inconsistent architecture. So, an example here is a utility that launched a project to predict outages and trips using historical data, but the data was too fragmented to perform it reliably. So what was needed was actually a set of a new project to try and bridge those gaps. So this is a considerable gap certainly for some use cases and at the fleet scale. So another utility, kind of preempting this understanding, took the time to document, organize, and integrate data sources across the entire fleet. But this can take money, and it takes time. But it's kind of the understanding that you get your data architecture right, then you'll have better tools in the future and more reliable outcomes. And you're also building trust with the workforce, in the beginning, which is important. If you start off on the wrong foot, it can be difficult to rebuild. I think the third one, coordination challenges. So this is kind of, I think the focus here is really cross-functional within the utility. So making sure that everyone's bought in to what's being done. People understand the different approaches being applied, and you kind of deal with the concerns preemptively that people may have, be it regulatory or cybersecurity or legal. I've certainly heard of cases where legal departments push back on AI deployment, worried about liability, IP, and AI-generated content being used inappropriately. And I think these are all legitimate, important questions to answer. How do you effectively maintain an audit trail? How do you document the basis for AI assisted decisions? And of course, IT governance and security, cybersecurity concerns. These are all important challenges to get a. Next slide, please. Okay, so we've walked through some of the early use cases and some of the key challenges, workforce adoption, data fragmentation, and coordination. So now we're going to walk through the ION AI framework a little bit more, and then the path forward. So, as we said, we're seeing across the industry that we're seeing a bunch of particular challenges related to specific use cases. And often we're seeing individual utilities solving these problems independently, making the same mistakes and reinventing similar solutions, and there's inefficiencies there. So that's kind of the guiding idea behind any framework like this, which is built at the industry level, and the ION AI framework is no different. It's about creating a structured approach to help utilities obviously based on the specific organizational context, but guide them so they don't have to start from scratch and deal with these challenges, individually. So the ION AI framework builds on the original ION framework, but moving from that integrated to intelligent approach. Why does this matter now? As we've said, there's this huge push for reinvigorating the nuclear industrial base and nuclear capacity overall. And of course, this is very much tied into the current administration's push for AI. You may have seen the recent publication on Genesis mission, and the DOE, INL, other programs, LWRS program, are actively working to make these targets a reality. So, as I said, AI is not this is a key enabler. This is kind of the key part. And then secondly, as my colleague Morgan will talk about after this slide, next generation fleet programs. So advanced reactors, they're being designed with digital and AI integration from the ground up. So this AI framework is kind of preempting that. So I'm going to quickly touch on, just cautious for time here, but quickly touch on the approach itself. So 4 phases. So phase 1, modernization, assessment, and planning. So this is really about understanding your starting point, understanding, what's the condition of your data infrastructure. We've talked about fragmentation. How good is it? What's the quality? What kind of projects do you need to implement to close those gaps? You may have lots of initiatives in AI or individual initiatives underway that you don't know about. You need to get a handle of those, and of course, relatedly, what's your organizational readiness for AI? Phase 2, so business case and regulatory support. So trying to understand what the ROI is for specific AI applications. We've built business cases using Ion previously, as Brian touched on. So this is critical for making the case for specific AI projects. And if you have the framework, basically, if you have experience of doing similar projects, you don't have to reinvent the wheel each time. And also the regulatory approvals as well, an important thing to touch on. Phase 3, implementation and change management. So I think we've talked about some of the change management aspects here. This is really doing the technical work, getting your sleeves rolled up and getting involved there. And finally, I think this is the fleet-wide scaling, and then the kind of final piece of Ion, where you move from pilot to deployment at the enterprise and fleet level. You can prove that AI tools work at one unit or a single department, but how do you scale that across the entire fleet? That's the true integrated intelligent operations. So with that, that gives a brief overview of the Ion framework. The next section, we're going to look in how this applies to the advanced reactors and the next generation of nuclear assets. But before that, Luke, you have any questions?
Yeah, we've got a couple questions that have come in. So the first one, Alex, is really around, do I need to deploy only generative AI to benefit from Ion? And are there specific nuclear AI tools that are being used other than the common models and the larger models like ChatGPT, Gemini, Claude, and others that are being deployed across the industry? So if you could speak a minute on that.
Sure. On the first point here, I think we've emphasized, there's a lot more than just generative AI, in the works, and that can be really beneficial. Take, the autonomous inspection example. So, several utilities are deploying robots, so ground robots, and then aerial drones for inspection. Some of this is autonomous, some of this is still manual, but very much involved in either case with machine learning to understand the data that you're looking at. So I think there's lots of low hanging fruit at nuclear plants for those sorts of use cases. As you said, there's the anomaly detection software that many plants are using. This predates the recent explosion in LLMs. I think LLMs can are certainly being integrated to improve the quality of those outputs. But the basic premise of Ion is that it's you get your data architecture right, your governance right, your workforce adoption right. That puts you in a place for deploying AI in general, including traditional machine learning, but and also your more modern LLMs. And in terms of the second question, yes, there are. I may look to other people within my team to answer this question, but yeah, there are specific vendors working with individual utilities to build nuclear specific LLMs. I think it's kind of critical to understand that you can't just throw ChatGPT or Claude at a problem like this. You have to have very domain specific training data to build for accuracy, and also you don't want your typical chatbot hallucinations. So yes, it's very much a critical component of building out that nuclear AI.
Yeah, no, that's good. Thank you, Alex. And some of those nuclear specific tools are trained on the NRC Adams database and other publicly available sources, and they have engineering and nuclear expertise on many of those vendor teams from what we've seen. So with that, we're going to transition now over to Morgan, and she's going to take us through the last section of this webinar in terms of applying AI to advanced nuclear. So advanced nuclears give the industry a chance really to do a lot of things differently with passive safety and a number of benefits from modular reactors and ability to scale. But we view this only if operating models are considered early. So we've seen some of the advanced nuclear and SMR companies bring in old talent from the legacy fleet who have a certain mindset and way of thinking about how to operate and run nuclear plants, which is very site centric and based on a lot of analog technology. Morgan's going to focus on how ION can be considered for advanced nuclear from a commercialization and deployment standpoint. So, Morgan, over to you.
All right. Thank you, Luke. And I do apologize. All my voice is going a little bit. I am a little sick, of course, going into the holidays. But all right, if we want to hit the first slide, perfect. So before we chat specifically ion with advanced nuclear, I just wanted to set the stage a little bit to make sure that we're all familiar with and understanding what we mean when we say advanced nuclear kind of and where we're at. So, a couple different ways to look at advanced nuclear. One is based on the technology. So, you've got a bunch of different things out there, a bunch of different companies going after stuff. So, what does all this mean? So first, you've got the current fleet is really considered the Gen 3 reactors. So Gen 3 plus reactors are using more proven technology. So they're similar to our current fleet by using light water as a coolant. They've got low enriched uranium as a fuel. There's big, small reactors with that. But again, kind of similar technology. And so you see that these tend to be the front runners because it's what's most familiar. And we've proven a lot of this already, just in a bit of a different way. So then if we start to look at Gen 4, and so, okay, well, what does that mean? These are totally new and innovative technologies. So thinking of things like gas, liquid metal, molten salt as coolants, totally different than light water, which we use now. Bit of a different fuel as well. And you can see again at the bottom, tons of different companies going after these various reactors as well. So the other thing then with these is size. So with the Gen 3 Plus, you've got your advanced reactors coming in large and small. So the current fleet, we consider those large reactors. There's reactors anywhere from, 700 megawatts to 1,000 plus. And then those are really the Gen 3 and some of those, like the Westinghouse AP1000. In my backyard, we got 2 new units, Vogtle 3 and 4 here in Georgia. And those are, again, considered kind of this Gen 3 plus advanced reactor. They also have small reactors or small modular reactors, which are typically 300 to 350 megawatts or less. And then as a sub part of small, you have micro reactors, so about 50 megawatts or less down to maybe 2 megawatts. And these are things that could be deployed, maybe, have on the back of a truck that you can trailer to a location, like a remote military base or something to power something, again, remote. So all sorts of different technologies and a whole lot of things going on right now with a whole lot of different reactor designers at play. So next slide kind of looks at what the overall landscape is then and kind of what some of these projects are going after. Hopefully by 2030, there's really aggressive targets. I know anyone in the nuclear industry is hoping to see all of this sooner rather than later, kind of crossing our fingers, right? But just things have yet to be kind of commercially deployed and proven. But there's a ton going on in the space. I mean, things are outdated almost within days of each other because there's so many announcements. But as you can see, the moral of the story is that there's a lot of projects going on and there's a lot of strategic partnerships happening. And so this isn't just the Dukes or the TBAs of the world, right? They're on this list, but they're partnering with these new companies, these new startups for some of the new reactor designs. And then, of course, you've got also these big tech companies who are all of a sudden in the energy space, also saying, hey, well, our data centers are really driving a lot of this demand. And, we want clean energy and we want it reliably and thus nuclear is a good response. So now that we've got what is advanced nuclear, and we can see that there's all sorts of things going on. So how does ion then help with driving this advanced nuclear? So if you go to the next slide. So the good news is we are in a great position right now to be able to deploy ion early because of the stages that we're in. So a lot of what the focus is right now is on designing the actual reactor, right? Proving the actual nuclear technologies. And so all the rest of that other stuff is still being decided, and we've got a really good opportunity to kind of get in now. And then the other thing is advanced nuclear is starting in a much better spot than what our current fleet is, right? So we just spoke a lot about how we can modernize our current fleet. And we're looking at that picture on the bottom right, this old analog control room where there's not a whole lot of digital. Maybe some of these sites have gone in and done a couple digital upgrades, but otherwise it's all analog. But the top photo is a photo of one of the Vogel Units 3 and 4 control rooms. And so as you can see, it's all digital, right? And so we're already a step ahead because we've got a lot of, it's more modern technology. We're already set up to have a digital infrastructure. So if we start to think about the ION model and how we can incorporate that now, we're going to be in a lot better spot for the owners and operators, right, as we sit and think how to integrate. So one of the examples that I'll provide here is a really simple way to think about something. So when I was at the nuclear plant, I remember one of our first outages. I went and just did a lap around the site, and the amount of scaffolding that is brought in and done prior to doing any work, right? So you got your outage, you got to go work on all this equipment or inspect it. And so you have to build a ton of scaffolding in order to be able to do these inspections. You've got pumps or valves that are, inaccessible, that are maybe 20, 30 feet up in the air, and you've got to be able to reach that to perform your work. Well, if you think about that early on and you can say, hey, what if the way that we designed the system, we made these things a bit more accessible, right? Maybe we didn't have to put it 20, 30 feet in the air, or maybe there's platforms or things that we could do to make this accessible. And then we're ultimately eliminating the need for scaffolding, which is not only time consuming, but it's really high in cost. Excuse me. It's one of, scaffolding is a very, very costly thing in outages. So if we get in early, again, we can kind of help shape. Go to the next slide then. We can then say, okay, well, how does this then integrate with everything else? And what does ION do? And really what we've talked about before, right? ION is building this foundation so that you can layer a bunch of stuff on top of it in order to optimize your fleet. And so instead of having siloed plants that we have nowadays, like Brian and Alex have talked about, right? Where each plant is kind of doing its own thing. They've got its own systems. They've got their own programs like fire protection, and everyone's doing them in silos. So you have a lot of redundancies. And if you're in nuclear, redundancy is important for some systems, but not necessarily for things like this. So ION really comes and says, okay, we can put all of these data systems on a common platform. We can share governance at the fleet level. We could share services, and we can not only support your current fleet, but we can be in a spot to then support advanced nuclear as well. So you're really able to scale, and not only just within your current fleet, but be ready for these new builds and these advanced reactors to come into play as well. Next slide. Just a little bit of a recap, right? So again, we've talked a lot about ION and what it enables. It's modernizing the workforce, right? It's these foundational pieces of data and technology that you can layer upon. It's fleet governance that you could actually scale across, current nuclear, across advanced nuclear. And ultimately, it's driving things like lower O&M, some shared services, and really standardized practices from day one. So not only modernizing the current fleet to provide that foundation, but then really getting us ready for integrating advanced reactors next.
Excellent. Thank you, Morgan. So a couple questions have come in. First one is really on the ownership structure, or who should own ION in an advanced reactor organization?
Good one. So I consider this a bit of a partnership. And really, it's going to be down to the fleet, or the owner operator needs to be the actual owner of ION, right? Vendors are going to be a key partner because they're the ones who need to, be able to help some of the digital design and some of those data interfaces and whatnot. But ultimately, the owner and operator are responsible for operating the plant, right? They're responsible for licensing. They're responsible for keeping those online long term and performance. And so, really, it needs to be that fleet governance and that these shared services models that are going to be driven by the owner or operator.
Very good. Another question is, how do you avoid locking in the wrong operating model while designs and regulations are still evolving? So we've seen a lot of movement on the regulatory front, additional executive orders trying to accelerate progress and shorten cycle times there. Um, Expected to help the industry, especially with the injection of capital from the federal government on the AP 1000 effort. But yeah, if you could speak to how do you avoid locking in the wrong operating model with everything else changing?
So, this is a really good question. I mean, I think, we've gotta be a little flexible, but there are things that we can do and standardize now to keep the rest of it modular, right? So we talk about, again, common data, like architecture, governance, thinking about building the foundation. We can then take the building blocks to layer on top. You can think about your whatever state procedures or whatever tools, AI that you want to put on top of that, but you've got to have the right infrastructure in place. And so it's more, I think we think of it as like a phased modernization approach where it's, let's build the foundations first. And then as we start to learn more about some of the regulatory aspect as well, they're likely going to have an influence on things like staffing levels. So we can then, start to kind of continue that and not be locked into something too early on.
Very good. Well, thank you, Morgan. So to wrap up, the key takeaway from today is really around the fact that modernization, AI, and advanced nuclear are all converging on the same requirement: a scalable, integrated operating model. And ION is not about optimizing today's fleet in isolation. It's really about enabling utilities to operate a combined fleet, as Morgan was referencing, legacy reactors, large new builds, and small modular reactors under a single coherent model. And so Scott Madden fits at the intersection of strategy and execution. So oftentimes we're known for operationalizing strategic initiatives or strategic imperatives. And so we help utilities in this case translate these concepts into prioritized, defensible programs aligned with regulatory, workforce capacity, and capital constraints. Importantly, we don't just believe there's a one size fits all answer here. So, as many of our speakers have said, these operating models are intended to be adapted for each given fleet or site, but base them on the same technology and principles as you've heard today. So the right path forward depends on your fleet, your organization, and your expansion goals, but it should be grounded in an ION model that leverages common data, technologies, and shared services to deliver work more efficiently and consistently across the sites. Where much of that today is done site specific. So we appreciate the discussion and the questions we got today, and we look forward to continuing the conversation, whether that's on modernization, AI readiness, or advanced reactor planning. Thanks everybody for your time and attention.
Thanks, Luke, and thank panelists. Fantastic presentation. And thanks again to Scott Madden for making today's event possible. For everyone tuning in, keep an eye out for a follow-up email with a link to the replay. And before you go, please take a quick moment to fill out our short survey. Your feedback helps us make each session even a little bit better. On behalf of the entire Energy Central team, thanks for spending a part of your day with us. We look forward to seeing you on an upcoming event.